Hello guys, now we are going to discuss the chemical reactions of carboxylic acid. As you are watching, we are doing the reactions of involving cleavage of OH bond representing the acidic nature of the acids. We can take sodium with acid, it will release hydrogen gas. We can take sodium hydroxide, it can also release water. We can take sodium bicarbonate, it will also release water and CO2. It means acids are acidic in nature, and acidity can be increased when electron withdrawing groups are attached. When electrons withdrawing groups are attached, and acidity can decrease when electron donating groups are attached. Some series I have written, whenever fluorine is attached, the acid is more acidic in nature, then nitro, then cyanide, then fluorine, then bromine, iodine, and so on, phenyl group. If I discuss, if vinyl group CH2 double bond CH or direct attachment of the vinyl or phenyl group also increase the acidity of the carboxylic acid due to resonance. If we are taking the vinyl group, you see that vinyl group is attaching with the acidic carbon in this manner, and resonatically it is stabilized and it is more acidic than normal. As you are watching, this bond will shift here and this goes to here. Finally, electron activity will increase. And if you see that what is coming here, CH2 get positive charge, C and hydrogen, this hydrogen is also here, and CH2C double bond C O negative, increasing electron activity, and OH. It means that is the carbonyl compound is when attached with the when attached with the carbon atom due to resonance, it will increase its acidic nature. This is not positive, normal sign. Vinyl group and electron will shift from this side to this side, and moreover, if I will take, this is the benzoic acid, as you all know very well. When some electron withdrawing group like as nitro group is attached with benzoic acid, it is more acidic than normal benzoic acid, and normal benzoic acid is more acidic when a plus I effect group OCH3 is attached. So these are the reactions which are representing that acidic in nature and involving the breakdown of OH bond. Next is that cleavage of COH bond. Next part is that cleavage of COH bond, same as we discussed earlier. Number one is that formation of anhydride. When I'll take two molecules of acid reacted in the presence of phosphorus pentoxide, acidic medium we are providing, we are getting acetic anhydride, that is known as ethanoic anhydride. Easily you can identify this way, CH3COO COCH3. You can meet one more. I'm remembering here that where you can use the P2O5. when you have to convert any amide into nitrile, suppose that I am taking here hexane amide, and hexane amide, if you would like to convert into the hexane nitrile, 1, 2, 3, 4, 5, 6, and then N. 1, 2, 3, 4, 5, 6. This is hexane nitrile. This can be, we can get by using of P2O5. My dear student, you please remember that by using P2O5, we can convert the amide into nitrile also. Amide into nitrile. Second is that esterification reaction. You know very well it, and it proves also that it gives in acetic acid, OH bond will be broken down, and alcohol will give H, and we are getting ethyl ethanoate. And the next is that simple reaction which we have done earlier in the haloalkane and haloarine, where PCl5 was there, side product must be phosphorus oxychloride POCl3. Whenever PCl3 is there, then side product H3PO3 phosphoric acid, and when SOCl2 is there, then SO2 and HCl is to be there. You must remember this one, my dear students. Then the next reaction is reaction with ammonia. The next reaction is reaction with ammonia. This is also very important. First, you will see that when we react with any acid with ammonia and we are heating it, it removes the water molecule and we are getting the amide. Here we are getting what? Ethane amide. This is example 1. Example 2, when we take the phthalic acid, it reacts with ammonia, strong heating we are getting phthalimide, and then strong heating and removal of ammonia will give you phthalimide. This is important product, and the next chapter amine we are using it. This is very important, my dear students. This is phthalimide. This is phthalimide. Be careful. Then next is that third type of reaction, reactions involving COOH group. Reactions involving COOH group. Number 1 reaction is that reduction, and you know very well that by reducing, acid can be converted into the alcohol, that is RCH to OH, and reducing agent you can take like as lithium aluminium hydride, LiAlH4, you can take B2H6 diborane, or you like. And then number 1 in reduction, that is RCOOH group is involving. Number 2, decarboxylation reaction, which we have done in the 11th standard also, where we will take sodium salt of acid, reacting it with soda lime, NaOH, CaO, you are getting 1 carbon atom less hydrocarbon with byproduct sodium carbonate. Simple reaction, you must remember this one. Alkali metal salt of carboxylic acid undergoes decarboxylation on electrolysis solution and form hydrocarbons having twice number of the carbon atom present in the alkyl group. Means of that, third reaction is that Kolbe reaction, electrolysis. Kolbe reaction is also an example of involving COOH group. Now the last reaction of the carboxylic acid, that is what the halogenation reaction. This is very important reaction, halogenation. This is commonly known as Hell-Willard-Zelensky reaction and written as HVZ reaction. This is called what? Hell-Willard-Zelensky reaction. Be careful, this reaction can be asked Hell-Willard Zelensky reaction. And be careful, one or two naming reaction will come without their name, and you are thinking that you have learned that properly. Suppose that I am taking here RCH2 CWH, it will attack on the alpha carbon, alpha hydrogen, this, and we are taking the halogen in the presence of red phosphorus, and we will get product on the alpha hydrogen. We are getting what? RCH here X and COOH. This is called Hell-Willard-Zelensky reaction. My dear student, this is over about the aldehyde, ketone and carboxylic acid. Last reactions you learn properly. Hell-Willard-Zelensky reaction. Important for examination point of view. Try to learn this reaction without name, because it can be asked, only it can be given that complete the reaction, and on that time you will forget. So please take care. Thank you guys. We will meet in the next lesson, that is amine. And CWH last reaction is ring substitution. I am writing up down. You please take care of this one also. If this is benzoic acid is given and we would like to do the nitration, so nitration HNO3 H2SO4 in the presence of done, and we will get the product meta product. Because of that, carboxylic acid is meta attracting, so be careful. Thank you guys, goodbye. We will meet in the next class with a new chapter, that is amines, important chapter. Any doubt, any query, please ask me. Thank you guys.